Okay, good day to Dr. Tehmiwa. Today we would like to present our project with topic bike sharing demand analysis and prediction. Here is table of content, and bike sharing system has revolutionized the way of people commute and interact with their cities. They provide the power of predictive modeling, step in to anticipate user demand, optimize fleet distribution, and enhance our system performance. This exploration into predictive modeling of bike sharing delves into the intricacies of how data-driven insight can propel this system forward. To achieve this analysis, we use schema procedure is by first to explore the feature that affect the bike sharing demand. Second, to develop a predictive model that accurately predict the demand of bike sharing. Third is to assess predictive model performance on the data. For data understanding, our data contains 18 columns with 17 change rows as a whole. This data contains hourly count of rental bike between year 2011 and 2012. So our data set is separated into two files for data integration demonstration, and some value was taken out to demonstrate how we handle missing value. So for data integration, we use Talent data integration to integrate this as file into the file. The node that we use in the Talent is a T file input delimited, T map, and T file output delimited. So we will insert the two CSV file into the T input, T file input, and then in the T map we will connect the two CSV file, and we will run the job and we will get the output. So schema is sample, explore, modify, model, and test. For sampling, first we cross the data source level from interval to nominal variable for attribute holiday, hour, month, weather, weekday, and working day. The TNT class will set as target variable. For the sampling, we choose certified random sampling with 20%. The result will show the same for 4 classes. It is better because to ensure the sample represent the overall data set. For exploration, univariate analysis, we found that weather on clear days show the highest frequency with 63.2% among the others, while Tuesday show the highest frequency with 15.6%, but the differences between the other day are relatively small. For winter, show the higher frequency among the others. It indicates the observation mostly during winter. While for the month, January show the highest peak followed by February. It is indicate the day of observation mostly around January and February. This for interval, the normalized temperature show normal distribution with missing value mean in the front. The wind speed is slightly skewed distribution with the highest in between 0.22 and 0.29, while the humidity shows slightly less skewed distribution with the highest in between 0.5 and 0.6.
So for bivariate analysis, we look at the trend. Looking at the bar chart, we can see the bike rental during spring and summer spike and the demand dip in fall and winter. This shows that the weather factor impact the bike rental count. Looking at the line chart, we can see there are 2 peaks. The demand is on the morning and evening rush hour, and the demand is slowly dip during working hours and late night. The multivariate analysis shows a 3D scatter plot showing the impact of temperature, humidity, and wind speed to the bike rental count. Here we can see the bike rental are most frequent in moderate temperature. Humidity show less impact, and only fewer rental occurs with increasing wind speed. So moving to the variable clustering analysis. So we perform variable clustering analysis to identify which factor or which features give more impact to the target variable. From the correlation matrix, it is apparent that variables CNT, temperature, hour, year has a strong and positive correlation to our target variable. Looking at the variable worth analysis, we do variable worth analysis is to identify key predictors to see which variable has a high influence in predicting the outcome. So based on the chart, we can see the total rental, which is CNT, registered casual variables, hours, and temperature are the key predictors. Whereas weekday, working day, and holiday are less or have lower influence. So we perform time series analysis on the bike sharing dataset to understand the past behavior or trend of the bike usage. Here we can see that there is an upward trend in registered user over 2 years, showing that the capital business has expanded with strong user base. And there is also a growth in casual rental user over the past 2 years, but it is less consistent compared to registered user, maybe due to the season and other external factors. Thank you.
I'll take over the presentation to talk about modification and data modeling. So we did some data cleaning for the data error. First, for the data inconsistency, we're using Talent data preparation to replace the minority to the majority. Moving on, we found missing value in the column better seed and A temperature. For the better seed, we fill in the missing value using the previous value because this is the time series data. And for the A temperature, we fill in the missing value using a linear regression. And here are the performance of the model. We show in the quite good because the R square is 0.974. Besides that, after comparing with the distribution of A temperature for the whole data set and for only the missing value, we found that there are significant difference in the pattern. So we found out that the A temperatures tend to miss when the value is very high, when the value is high. So we make a conclusion that the missing value in A temperature is missing value not at random. So besides the data cleaning, we also did some feature engineering. We dropped these 4 columns due to this reason. So this step is to further improve the accuracy and the performance of our model. Next, before we moving on to the data modeling, we did some data splitting into training and validation set. So the ratio is in 7:3. In this project, we did 2 types of modeling, which are regression and classification. In the regression, the target is CNT, and the evaluation metric is RASE, MAS, and R square. While for the classification, we using target variable CNT class, which is derived from CNT, and our evaluation metric is misclassification rate, because this one can help us to calculate the accuracy. So we apply some model in this project, in both regression and classification. So we apply logistic regression, decision tree, random forest, gradient boosting, neural network, auto neural, and last assemble model. In assemble model, we assemble gradient boosting and decision tree. So we also did some hyperparameter tuning in random forest and gradient boosting, and after applying the tuning, the performance of model increased, especially in gradient boosting. You can see that no matter in the classification or the regression, the RASE and the misclassification rate decreased when we tune the math step.
Now, I'm going to present for the time series analysis and forecasting. The time series autocorrelation graph has been plotted. As we can see from graph, the autocorrelation get lower when the time lag increase. The time series similarity also have been plotted in order to study that the column that has higher similarity to the count. From this graph, we can know that the average temperature and temperature has the highest similarity to the count. The time series exponential smoothing also have been plotted in order to know that the forecast value. The forecast value can be found from here, which is the graph that behind this line. So for the access part, I'm going to present for the access part. For the access part, we have done the model comparison for the regression problem and classification problem. From this table, it is a regression model performance. From this graph, we can know that the gradient boost has outperformed among the trend model. The second best performance is the assemble model, followed by the decision tree. The worst performance model is the logistic regression. For the model from this table, it is include the performance of the model for classification problem. The gradient boost has outperformed among the trend model, and the second best performance is the neural network model, and followed by the third is the assemble model. The worst performance is the auto neural models. We also plot the graph analysis for 7 trend model for the regression problem in order to know that the mean predictor and the mean target difference. So this is all of the graph for the 7 models. So from the graph analysis, we can know that the gradient boosting with the max depth of 6 with hyperparameter method that apply, the mean predictor and the mean target are the most correctly, which means that the performance of the model is considered good. So for the important of variable is also studied in this stage. For the regression model and classification model, the random forest decision tree and gradient boosting show that the hour and average temperature are the important variable. Next, for the conclusions, in this project, we have successfully implemented the SEMA process for our project. In the sample stage, we have used 3 methods, which is the systematic, random, and stratified sampling method to sample our dataset. And finally, the stratified will be used for the next stage. For the explore stage, we have plotted the univariate, bivariate, multivariate variable clustering and time series analysis in order to explore more on the dataset. For the modified step, we have done the data cleaning and feature selection. For the model stage, we have trained 7 models for the regression and 7 models for the classification. And for both problems, the attribute outperform among the trained models. The time series forecasting model is also has been trained in order to know that the future count value. For the access stage, we have compared all the performance of the trend model in the model stage. That's all from our presentation. Thank you.